welcome to our web seminar today. Today I will talk about software. It's our Smart Lab Color software. It's a QC software for online control in the lab. Before we start, let me introduce myself. My name is Henrik Vogts. I'm working now for Big Gartner since 23 years and focusing on training, education, and on the web seminars. Some general information about this webinar. You are muted when you are entering this web seminar. So that's why, please, if you have any questions, please document those questions with the chat function. You find the chat function on the right side of your screen. And I will try to answer all your questions at the end of this web seminar. The idea is to have 45 minutes of presentation and then some time left for your questions. If it's not possible to answer all your questions, feel free to contact me or to contact your representatives from Big Gartner, in your region. Next week, you will get not an email with a PDF file because today it's different. So it's not a PowerPoint presentation. I will show you live the software options. So that's why I can show you where you can find the recording. We will put the recording on our website as always. For reviewing, you see on the Book-Instruments website, you have the option. Click on support, please, and then you find continuing education services, seminars, and web seminars. And here it splits into one-day seminars and online web seminars. And they are all listed here. And some have a recording still available. Normally it's for 4 weeks available after the event. So you see here QC software online control. And when you click on it here, you will find later the webinar recording down here. Okay, this is only for the start to give you this information. And now back to our topic today. For that, I've put together this agenda. So I will start out with explaining the smart chart packages. So we have a smart process, we have a smart lab, and I will talk about the basics and the structure behind. Then focusing on smart lab, I will explain options for data analysis. I will talk about standard management. It's very important because in standard management, you can define, for example, pass-fail parameter. So those parameters you have defined with your customers. And I will show you how to do that and where you can find it. And one topic to highlight is how to create a digital standard. So digital standard is a concept that is used more and more in the industry to avoid the shortcomings you have with physical standards. When you send around physical standards, they maybe change color in future. They are not treated well. They are not measured in the right way. So that then you are always have the risk that you get differences And when you have agreed on tight tolerances, you want to avoid those differences. And with the digital standard concept, so the standard is measured with one instrument, and then you send just the data file, and your suppliers can upload this data file into their instrument. So, and then you have no differences. And then I will point out on some functions of the smart lab software. So, for example, how easy it is to swap, sorry, between standard and sample, and so on. Okay, in general, smart chart. We have two packages. We have the smart lab package, so it's designed for online measurement and for memory transfer. What does it mean, memory transfer? It is you measure everything first just with the instrument, then it's only stored in the instrument, and then you can send it to the software package. Or you hook it up by a cable or by a LAN connection, and then you have direct online. You measure it and you immediately see it in the software. Smart Lab offers a lot of data analysis options with all color systems, and a lot of graphs are available. I will show you later. And as you know, our Spectro 2 guide instrument, that is for solid color, this instrument is more or less three instruments in one. It measures color, it measures gloss, and it measures fluorescent, or it detects fluorescent components inside the coating. So, and this is nice for color stability check. The second package, Smart Process. Smart Process is designed for standardized QC. So you can have a sampling process with digital standards defined in organizers, and the organizers are key in Smart Process. I will show you in a minute. At the end, you collect all in one database. So this is called also big data. You can, for example, if you know you measure, or you have to measure, or you are producing in the next 3 years 150,000 whatever refrigerators, and you want to control that, you want to monitor that, then it's nice to have an organizer. So organizer is defining the check zones, and you can collect all this data, and then you can filter. You can filter out of the big database by color, by product, by customer, whatever your input was before. Okay, now I can close the PowerPoint. I can leave the PowerPoint, and we switch directly to the software packages. So this will be the setup when you have bought, for example, a Spectro 2 guide. You see the instrument here. This is a simulation, a working simulation. And when you have decided on the smart lab. But first of all, let me show smart chart in total. So here you see all options available based on the instrument you have bought before. You see the smart chart is designed for a lot of instruments we offer. You see the smart lab, for example, is designed for also for the bookmap. Bookmap means multi-angle color measurement. The smart lab is designed for the Spectro 2 guide. We will talk about this later. And you can connect the smart lab to the Spectro 2 profiler. The Spectro 2 profiler, a new instrument. This is made for color measurement, for gloss measurement, and for structure, for surface measurement. It describes, it uses camera technology to analyze a surface structure. And the smart lab is available for our gloss instruments. And the smart lab is available for our haste guard instruments. For the haste guard is made to measure transparency of foils, of glass, of eyeglasses, and so on and so on. You see, the smart process, to give you an idea, the smart process is designed to work with organizers and to collect a lot of data. Again, you see smart process works with a bookmark. When you buy a bookmark, you can decide to have a smart process or the smart lab software. And as always, you get 2 licenses. So you get a 30-day trial, and then you have to decide smart lab or smart process. This is for the bookmark, you see. The smart process also works with the cloud runner. The cloud runner is an instrument to measure light dark variations on bigger areas, the cloudiness or the modeling. Then it's designed for the wave scan. The wave scan, in automotive, they are checking orange peel, for example, or long wave, short wave, and WA, WB, WC, and so on. Maybe you know these values. Again, the smart process works with gloss instruments, the Spectro 2 guide for sure, the Spectro profiler. To give you an idea, when I click on, let's say, Spectro 2 guide, um, first or most important is to define the test procedure. You have a product and you want to measure a lot of checked zones. I can change schematic. That's very easy. Let's take a refrigerator, for example. I select it. So, and the idea is on the refrigerator, for example, you define your checked zones. So here I have a pretty easy setup. 1, 2, 3 checked zones. So, and this setup, this organizer, you can transfer to the instrument. And when you are in production, then you recall these organizer, and then you get displayed on the screen, please measure check zone 1, check zone 2, 3, and so on. And afterwards, you send it back to the big database, and then you can run analysis for the last 3 months or the last year, and so on and so on. So this is the overall concept of the smart process. Okay, for smart process, we will have in future web seminar. There's also a general part. This general part is with smart lab and with smart process. So that's why, I have all instruments here hooked up. So that's why you see them, you see all these options. When you, for example, buy a Spectro 2 guide, you will see this setup here. So the general options are, to explain them briefly, in standard management. We will come back to this later, but in standard management, you define your settings around a standard. You define a color system. You define tolerances, you see here. You can define additional illuminance. You can define how often to measure a standard, how often you do averaging on a sample. Okay, later more to on standard management. I want to save it. Instrument management, also pretty easy to explain. It's instrument management comparing or compares what is stored in the instrument on this side and what is stored in the database, or what is stored on both sides. You see it here. So this standard here, these measurements are only stored in the instrument, and now I can transfer it to the database by clicking on here. And these standards are for other instruments. That's why they are highlighted in red, for example. Okay, configuration. Configuration gives you some options, some general options, like you can change the language, for example, or you can manage your databases, the location of the database. You can manage the instruments. You see, for now, I have connected here two instruments. It's a Spectro 2 guide by a USB connection. It's on my desk. You cannot see it. And I have these virtual instruments, these simulation, and this is the Spectro 2 guide D8, so diffused 8 or a sphere geometry instrument. And this is a 450 instrument. You see it here um, in the name. So you can manage your measurement database, you can run a database backup, you can manage your organizers when you have the process software, you can manage the schematics. So you can always upload your own schematics. You can upload, you see I've uploaded here some just pictures, you know. You can upload what you want. And then for defining your check zones, you can manage the catalogs in, this is for the process software. What is of interest for the Spectro 2 guide and the Smart Lab software is here you can manage the options. You can give permissions. You see down here in Smart Lab, you can give delete data permission or not, or you can give edit standard permission. So you can manage those permissions. Okay, these are the overall options Smart Chart offers. Now we focus on the Spectro 2 guide, the instrument that measures color, gloss, and detects for some fluorescence in the coating. First of all, I will show you with the simulation how easy it is to get some readings to come to some results, because I know a lot of customers, they like to use the quick check option. Quick check option means no additional input. So this is a touch screen. I click on quick check and now I can measure. You see my setup is average out of 5, because it's always good to do averaging on a sample. So 5 different spots on the sample. And now I can measure very quick by clicking here or touching here on the screen. I say measure 1, 2, 3, 4, 5. You see the numbers. So this simulation creates random numbers. I click on forward, and now it's waiting for the sample measurement. You see the setting, the software setting is 3 measurements on the sample. Again, I measure 1, 2, 3, and you come to deltas. You come to the results you normally want to see. You want to see the delta E, and you want to see the delta L, A, and B. And this offers more. You can slide the screen here and you see the LAB plot. And on the other side, for example, you see the gloss numbers, sorry, for the 60-degree gloss values. Okay, that is very quick to check something, to perform a color measurement. Now we assume that we have connected it to our software, to the Smart Lab software. The smart lab software at all is organized, or the data structure is organized by files or by projects. So a project can be all measurements for a customer, or all measurements for a special color for a customer, and so on. So this depends on how you want to organize those files, and then you can store them where you want. So that is a free concept, just in files. And if you want, you can transfer this from the files into a database. But in the first step, it's only in files. So to show how quick, again, we can come here to results, I just choose a new project. I want to measure a standard, add standard, measure a standard. Now the instrument is connected automatically, and I want to connect the simulation. You see, this switches to online mode. And now again, I have to measure 5 times. So you see here, you can use the mouse, or you can the pointer, or you can use F2. And I will like to work with these keys. So I take F2, 1, 2, 3, 4, 5 measurements. So I can say, okay, apply means F4. And then it's waiting for the measurements of the sample. Again, F2, 1, 2, 3. So now I can end this test series, or I can measure the next sample. You see, F3 means measure next sample. The naming is automatically, so I have done no input. It jumps one number up or higher from sample 1 to sample 2. Measure again, F2, 1, 2, 3. Measure next sample means F3. Again, 1, 2, 3. I want to have 5 samples, so next sample, F3, measure with F2, 1, 2, 3. One more, next one, F3, and measure 1, 2, 3. And if I want to end the test series, I press F4, for example. So these keys, these shortcuts are a new function in the newest version of the Smart Lab. And you see, without any additional input, we get an analysis, we get color numbers, and we see differences on screen. So I can make this a little bit smaller so that we see all the readings. Okay, I click on this. So the simulation creates random numbers, but not so big differences as designed. You see, at all, we get the status, a pass-fail status. They are all green because you see the delta E is not so big. So we see on, for sample number 1, it's 0.46, sample number 2, 0.4, 0.7, 0.1, and 0.2 or 0.3 nearly. So you see what happens when I highlight sample number 1. It's automatically highlighting the sample in the LAB plot. You can use it, or you can click it. When clicking here, you see it's highlighted here, or you click here, it's highlighted here. So you can use it like you want. And with mouse rollover, by the way, you see the naming and the numbers. This is sample number 2. This is sample number 1. And this, with the highest differences, you see it's sample number 3, or I click on it, then it's highlighted in the table and it's highlighted in the LAB plot. So The LAB plot you see, I see because I had clicked on scatter graph. When I click on table, I just see the table. So pretty easy, straightforward. When I click on line, this is more of interest, I guess. Then you get the, let's say, the behavior over time. And you see the limits. You see the warning high limit. Here, this green dotted line. Warning high means 0.7. So the overall tolerance is plus minus 1. And the warning level is plus minus 0.7. So 70% of the overall limits. And this you'd see for delta L, delta A, and delta B. You see we have no limits defined for delta E, and we have no limits defined for gloss, for example. We can define this. I will show you where you can define this later. Okay, scatter we have seen. Metamerism, we see results from metamerism, we see only when we have defined more than one light sources. For the moment, we get the analysis only for D65. So I will show you this option a little bit later. First, I want to click on spectrum. Spectrum, some like to see the spectrum, the curves, the measurement curves. This is what we call the fingerprint of color. You can highlight this. And by highlighting this opens here on my second screen. That's why I have to move it to this screen I shared. You see, clicking on standard, it's highlighting here. This is the fingerprint, the reflection curve, the remission curve of the standard. Clicking on the blue one, this is the sample. So in this way, you can toggle through all the measurements you have. Okay, I will close that. Fluorescence, we will talk about in future in a coming web seminar. What we have here as an option, again, it's changing the screen. So then you get just the setup that all the graphs are on the right side, and here you see that the graphs are underneath the data table. What is also a new option in print, again, a screen opens on my second screen. I will share it with you here. So in print, you can define your report. So you can add some output, or you can uncheck one output, so that it's possible to create a one-page report, and you can add a comment, or you can upload your own logo here. That is all possible when using configuration. Again, on my second screen, window is opening. So here you get a lot of options to create your own reports, your own printouts. The last option in this row, often used by customers, is export. Export means export to Excel. I took a name, export from today. Yes, I want to override it. And then an Excel sheet will open, and what you get is the export of the data table with the pass-fail status and with some coloring behind, so, and all the limits, and this is really often used by our customers. So now we have talked about all these options in here. So let me point out here these what is available here. Often customers are just measuring samples, so they have not defined standards. The idea is to define a standard out of some samples, for example. So here, this option, this is possible when highlighting maybe this sample, and this sample. And then please use the right mouse click, and then you get more options to manage these samples, these highlighted samples. You see, and one option is you can copy those as a new standard. So, or let's say the average as a new standard. Or you can save here the data in a test series, or you can just copy, cut, delete data here. So average is a new standard. I click on it. Now you see I have a new standard, and the software is waiting for input for a new test series, for new samples. What you can do instead is you can measure here, or you just take maybe this one and this one. Oh, too much. I only want this one. I want this one and I want this one. And I can copy them and I can paste them here. So then I have created a new analysis setup based on a new standard, on a standard I have created out of 3 samples, for example. So this is very flexible. The right mouse click gives you here a lot of options, so feel free to try it out. Okay, more options here. You see, you can save it. You can save these file, these projects with save as. And I have to give a name for this. Let's say it's a new project for a new customer, for example. Okay, I save it. And when I leave now this part of the software, you see it's in my project list. And you see by mouse roll over, it's stored in data, smart chart, and so on and so on. You can store it wherever you want. So if you have more smart labs installed in your company, you can share those files, or you can store the data inside those files in a measurement database, for example. And here you can recall this file, this project. Just open this project again, and you get the last status. What's also new and important is here we see deltas. You see delta L, A, B, and delta E Some customers like to see just absolute color numbers. Again, you see it switches from deltas to absolute numbers, L, A, and B. And you can have both. You can have, I will just the table, show you just the table. Here you see absolute numbers of the samples, absolute numbers of the standard, and the deltas. And this option calculates automatically the average out of all samples listed here in the data table. So it's more or less the same as if you are highlighting them all and then average as a new sample. So, then you get this one here, and these are the same numbers then in this row here. Okay. Important functions, just quick explain. Browse project brings you back to this screen where you have stored all your projects. You can recall old projects, or you can just one step back and then you can recall your projects here, for example. So that is pretty easy. Open. You can always add, if you want, a new standard inside the project. Just click on it. You can measure it. You can load it from the database, or you can download it from the instrument. So now I click on this and I select the instrument, I select the simulation, and then I get listed all the standards stored in the instrument. Let me take this one here. And by clicking on here, I see what is behind, what is the setting behind of this standard. I can say apply, and then I have downloaded this standard here from this simulated instrument, for example. When I click on test series, or I click on one sample in a test series, then I can add a measurement to this test series. You see, it offers me again the option to measure F2. I take 1, 2, 3, and to end test series, I can use F4. And now I have 6 measurements. 6 measurements compared against standard number 1. So only the last is highlighted. That's why you see only sample number 6. When I click on test series, you see them all. Or when you click on standards, you see them all. Okay, now let's see what's left. So opacity measurement is also for a coming web seminar. Very important is the option properties. Now I have highlighted properties. When I click on it, you see I get the same screen I had before in standard management. In properties, it's easy in the first step to change the name to new name, for example. In properties, you can change the color difference method, for example. You can change it to delta E CMC, or you can change it to delta E94, for example. And you can define your pass-fail criteria. You see, when we put it to plus minus 1, the warning level is by 70% of 1. That's why we get this 0.7, for example, by the way. And we can define fluorescence limits, but this is again for a future webinar. In addition, you can also define some statistics options. You can see min, max, values, standard deviation, range, and so on. You can also add, this I want to show you, is additional illuminants. To see metamerism or to check for metamerism, you need additional illuminants. So that's why I choose A, tungsten, and I will choose, in North America, often F2 is used, or F2 is called, before the name was CWF, for cool white fluorescence, for example. So I add those illuminants to the in the standard setting, in the standard properties. And now let me apply this one. And you see, you get recalculated values, because we have these modifications. So light sources are only values, and now the numbers are recalculated. And we get, in addition, and now too much data, I will reduce it to, I will shrink it to just deltas. And now we get the deltas for D65, for A, and for F2. And you see they are more or less in the same area, the same, it's 0 point something, nothing, no big numbers in difference. When I click now on scatter, you see 3 scatter graphs for each light source. And more of interest is the metamerism screen. And now you see a setup. I will try to make it a little bit bigger so that it's easier to see. So this here belongs to one sample. When I do a mouse roll over, you see this is sample number 2, the analysis for F2, for this illuminant F2. This is sample, the result, sample number 2 for A. And this is the results, sample number 2 for D65. You see, there is a difference from here to here. This is indication that you have maybe metamerism within your standard compared to the sample, because this distance is bigger. When you see here, this is sample number 5. The results for all 3 light sources are more or less in the same area. So no big difference between the light sources and the delta numbers for the light sources. So, and this is a good indication for that you have no metamerism problem with your sample compared to the standard. This is a nice overview, a quick, nice overview for which samples maybe cause problems or which are fine when checking for metamerism. Okay, the last option I want to show you is digital standard. You see a digital standard when you go to properties for a standard and clicking on values, you see that the measurement values behind this name. The standard name is I've renamed it to new name, and then you get the LAB values. And here you can define the standard to a master. And this master now you can use as a digital standard. So, but here we have no options to export the master. So that's why for a digital standard um, we have to use the standard management option. It's nearly the same like properties, but in addition, you have here the option to export a standard. When I click on export, then XML file is created, and this can be sent by email to your suppliers, and they can upload this XML file to their instruments. They need the same type of instrument. If you have a Spectro 2 Guide 450, your suppliers also need a Spectro Guide 450, so that they can upload and that they can work with these digital standards. So for that, on the other side, they have the same software set up. They can import this file and send it to their instrument. Okay, this is more or less all I want to share today about Smart Lab. And now let's have a look if you have if there are some questions. Written in the chat. Okay, I see. This is an interesting question. How do you add a virtual instrument to your instrument list? It's designed to show up there. You know, the virtual instrument has address, and I can key in this address. I will show you. It's not a secret. In configuration and in instruments, you know, if you add an instrument an IP address, the virtual instrument has an IP address, and I can add a name and an IP address, and then it will show up in my instrument list. So, you know, so it's that is designed by our software engineers, that it works like this. So I can see when I go to the virtual instrument, it has configuration and information, and you see this is the IP address of the virtual of the simulation of an instrument. Okay, more questions I don't see for the moment. So okay, I guess you get some useful information from from this session. Okay, I would like to thank you for listening today, and I hope you will come back for our coming web seminars. And for today, I wish you a nice and successful remaining day. Thanks for now, and bye.